And we're going to, first of all, in doing this process, we're going to compute the IQR. The IQR is the interquartile range. It is equal to Q3 minus Q1. So the IQR is equal to my third quartile 64.6, minus my first quartile, 57.2. So 64.6 minus my 62.6. Sometimes my memory is not very good, so I'll go back here and, oh, it wasn't. My memory was terrible. 64.6 minus my 57.2, and then we'll calculate that. So let me erase this because that was totally way off base and rewrite it correctly, 57.2. And that value, that difference, that interquartile range is actually 7.4. Now, after I have the interquartile range, my second step is to multiply that interquartile range by 1.5. And again, I could go into a big long explanation of why I'm multiplying it by 1.5, but suffice it to say it has a lot to do with the empirical rule. So I have 1.5 times that value. And a lot of times if I don't have a calculator, I'll just do this by multiplying by 3/2 because it's easier for me to do if I don't have that calculator. And that value gives me 11.1. Now once I have this, the next thing that I need to do is I need to find my fences. Now my fences, these are just the high and the low values. So my low value in my fence comes from my first quartile minus the 1.5 times my IQR. So my first quartile, that's my low number, 57.2. So 57.2 here, minus 11.1. And I'm going to find out what that value is equal to. So 57.2 minus 11.1, which gives me 46.1. So 46.1. Now that's my lower fence. Now my high fence, that one is my third quartile plus 1.5 times the IQR. So this one starts out with my high number, 64.6, and then it adds 11.1. So this one is going to give me 75.7. And those are my fences, okay? So these are my fences. So what this means is that I now have a range of data, 46.1 up to 75.7, that I would expect to contain my normal data, ones that are not potential outliers. So let me go draw this on a number line because some people find it really helpful to see this visually. So if I say, okay, here's my number line, and over here I have that high value, that 75.7 it was, let's see, 6475.7, that 75.7 over here, and I have my low value over here of 46.1. This is the area where I would expect to find the usual data, the normal data, right? Expect and I'm going to say normal, and this has some special connotations for us later, so I'm going to put it in some quotation marks here. So what I'm going to be looking for to see if I have any potential outliers is I'm going to go back to my data, and I'm going to actually look at my data, and I'm going to say, okay, oops, I have to scroll this down so you can see it. that I want to see where my data is. So I'm going to put in red here where my data points are. Now, this isn't to scale or anything, so just forgive me. So I have my low one here at 50.2. And then I have data kind of scattered out in here, right? There's all kinds of data in here. I'll just kind of, do this. And then I have this last one here. We'll call this the last one here 69.4. And then I have this one out here at 77.1. And what you see is that this one at 77.1 lies outside my fences here, and that's a real problem. So what we have going on is the data being outside the fence really is worrisome for us, and that right there is what signals this potential outlier. So this one here says that this 77.1 is a potential outlier. Now that isn't going to say, oh, well, if it's an outlier, then I'm automatically going to throw it out. But it is something then to be concerned about, to investigate further. And that's what statistics is about, is in recognizing what's going on, what you expect to see, if things are different than you expect to see, why are they different? Is there sampling error? Is this just non-sampling error? Is our sample not representative of the population? Has our population changed? What exactly is going on? And these are all questions that we want to raise as we start seeing these things. So that is our interquartile range. And this interquartile range begins something that we call exploratory data analysis. And exploratory data analysis, also called EDA, that's just an investigation. And you want to say, okay, well, now that I know a little bit about my sample, let's see where that takes us. And the hinge of the exploratory data analysis is all these summary statistics that we're gathering, the visual summaries of the data and the mathematical summaries of the data. And what is the data telling us? Remember, the data is meant to, so to speak to us. If you watch any of those real popular cop shows, right, they always talk about the evidence speaking to the detectives. Well, that's what we are. We're detectives. We're detectives looking at information and trying to find out what a population looks like based upon this sample information that we're given. So we want to see, what does this data speak to us about? Does it tell us that we're getting the population we expect, or is it telling us that it's different from the population that we expect? If it's different from the population that we expect, is that because the populations maybe changed over time, or is it something that happened as we were collecting data? Did we happen on a subpopulation within the population? What happened and why did it happen? And that's really what exploratory data analysis is. And we are learning the tools for that exploratory data analysis in this chapter 3. As I said, most chapter 3s will do in most beginning statistics textbooks. Now, the next thing in our exploratory data analysis is another visual. Now, this visual isn't usually discussed until we get to this point because we don't have all of the ability or all the skills in place so that we can draw this. So the next thing that we're going to talk about is something called a box and whisker plot, or just sometimes called a box plot. It's called a box and whisker plot because a box and whisker plot looks like a box. It has a line in the middle of it, by the way, and then it has these things that look like whiskers. So we call it a box and whisker plot, or just short, a box plot. And this box plot is based upon our 5-number summary. So our 5-number summary is something that we can't do until we find out about percentiles and quartiles. So based on what we call a 5-number summary. And the 5-number summary, quite easily put, says what is the minimum data point, what is our first quartile, what is our median, also called our second quartile, and what is our third quartile, and what is our maximum. That is a 5-number summary. And this creates this box plot. This is our minimum value. This line here is our first quartile. This middle one is our median. This last upright of the box is our third quartile, and this over here is our maximum. Now, one of the things that's really super important to me is that this is a scaled drawing. It does not mean anything unless it is scaled, because the relationship of all of these points helps us to see the shape of the data. So the one that I've drawn here is a pretty symmetric shape. We have the median pretty much right smack dab in the middle. The central box is a little small. This is a little long on the tails of this, because we should expect to see that this encompasses about 75% of the entire graph, minimum to maximum values, and the tails on each side about symmetric. Now, this box being shifted to one side or the other tells us about skew, but also the median being shifted to one side or the other can tell us about skew as well. So we have a couple of indicators of skew, and then the length of these tails helping to further that idea of skewness. So let's go ahead and take a look at our purse snatcher data again, I think it is. No, I don't have purse snatcher here. Let's go ahead and take a look at the purse snatcher data, and I'll let you guys do this one on your own and give it a try. So let's go look at purse snatcher data.